Hi everyone and welcome back. This is PI Planning Section 3 where we will be going into some detail about the ART Backlog. Topics for Section 3. First of all, we'll look at the role of the ART Backlog in SAFE. We'll look at what kinds of things should be in the ART Backlog and why. Then we'll review the difference between epics and features and the portfolio backlog and ART backlogs as they are used in SAFE. We'll then look at a sample template that we might use to capture feature information. And then we'll discuss what level of refinement and detail is going to be needed to support PI planning. And finally, we'll look at the weighted shortest job first, or WSJF, method of ranking ART backlog items. So let's look at the role of the ART backlog in SAFE. So for every product that an organization provides to its customers, there should be a product goal or product vision that represents the long-term objective for the product and towards which the team is working. How the vision or product goal is to be achieved is reflected in a strategy. Strategy basically means how the organization decides to compete in the marketplace to achieve competitive advantage. So strategy acts as a filter for what kinds of high-level business goals or initiatives should be pursued by the organization. And in SAFE, we use the portfolio backlog to track these initiatives. It should also be noted that whether we have a multi-product business or a business focused on a single product, we still capture high-level business goals in something called the portfolio backlog. In SAFE, then, the portfolio backlog items are referred to as epics, which are large initiatives representing major business and technical objectives, potentially requiring multiple PI time boxes to fully implement. So whereas the product backlog contains a set of major business goals or initiatives designed to deliver the strategy, the ART backlog contains items that reflect actual solutions for the business objectives, otherwise known as product features. The ART backlog is ordered so that it represents the work needed to achieve the highest priority business goals for the next PI time box. So, ART backlog is a rank list of features and technology enablers needed to achieve the goals for the next PI. It's aligned with product vision and strategy via the portfolio backlog. It is owned by the ART product manager. It is then refined in preparation for PI planning. Items in the ART backlog are stack ranked, and the ART backlog is the primary input to the next PI planning event. So now let's pause for a minute and recap to review the basic definitions and differences between items in the portfolio backlog and the ART backlog, that is epics and features. So epics live in the portfolio backlog, represent large development initiatives to achieve significant business goals, require significant investment, and this requires something called a lean business case, and we'll need to refer to the lean portfolio management core competency for a deep dive on that topic. May require multiple PIs to complete, may also need the work of multiple ARTs to complete. Epic description is recommended that we capture it in a so-called elevator pitch format. We have an example of that coming up. Epic should have a dedicated owner who will work with the ART product manager and system architect to decompose epics into features as part of the solution. And then for features, features are solutions to these business initiatives. They are captured on the ART backlog. They represent solution functionality. They're sized to fit in a single PI. So a feature, the intent is not to have features roll over multiple PIs, but are scoped to fit in a single PI. Features have acceptance criteria, that is, we have an unambiguous definition of expected behavior, which serves to delineate the scope of what is required or not required. Both functional and non-functional requirements should be identified in the feature. And then finally, we have these things called enablers, or architectural runway items. So this represents architectural or technical infrastructure work required to support any proposed features. So now let's take a look at the kind of information we would expect to see captured in an epic. And again, epics are items that reside on the portfolio backlog and represent major business initiatives. So in this example, we have epic name, epic owner, and then we have this format called the elevator pitch used to describe the epic. And this good example of this, or more information about this, can be found in Jeffrey Moore's book, Crossing the Chasm. So as an example might be for mortgage originators who provide home financing services. Our product is a web-based application that quickly qualifies borrowers. Unlike existing originators at major financial institutions, our solution provides loan approvals in under 1 hour. And we just made that up as an example to give you the general idea of how to describe an epic. The business objective, in this case, this example might be penetrate the home lending market if it's a new product. And a KPI, a leading indicator, might be something like the number of software licenses sold per quarter. And so here's an example of how we might use OKRs, objectives and key results, to capture business outcomes in the Epic template. So in this case, we have two OKRs, and the first one, objective 1, is something like improve sales conversion rate by 25%. And the specific key results, which are very specific and measurable, we have 3 in this for objective 1, namely all search results accompanied by high resolution images, shopping cart reminder alerts, and customers also bought related purchases alerts. So these 3 things might be implemented as features in the upcoming PI as part of objective 1. The ART backlog should contain everything needed to realize the goals for the next PI. So this is going to be a ranked list of product features plus any technology enabler items, things like database upgrades, changes or upgrades to UI frameworks and so on. And then each feature must be sufficiently well defined to enable teams to create user stories and associated effort estimates during PI planning. So we're not going to have much time during PI planning to flesh out all the details of these features. This must be done before the PI planning event. So the template shown here is designed to support that. So we have benefits, why is the feature needed, what business objective does it support, and then acceptance criteria. These help establish a boundary around the scope of the feature and can be a good starting point for identifying initial user stories. It can sometimes also be helpful to call out any functionality here that is specifically out of scope for the feature or out of scope for the PI. NFRs, non-functional requirements, these are things like performance, capacity, reliability, regulatory constraints, and so forth. And then finally, some initial size estimate, and obviously we don't have a real estimate for the feature at this point. So this can be a coarse-grained estimate, perhaps simply small, medium, and large. at least confirming that the feature can be deliverable in a single PI. Now let's pull all of these concepts together, showing how product vision, portfolio epics, and features are connected. Everything starts with the product vision and a strategy to achieve it. Strategy is realized through a set of initiatives captured as epics in the portfolio backlog. And from there, each epic is elaborated into one or more product features and or technology enabler items. These items make up the ART backlog. So the example we have here is we have a business goal of improving sales conversion rates by 25%. This is being addressed or supported by adding a feature to the product to provide high resolution product images with all search results. Presumably this is a e-commerce system. This feature is captured in the ART backlog, where it is then refined to a level of detail reflected in the template reviewed in the previous slide, and is also ranked against all of the other backlog items. And then this backlog is the input into the next PI planning event. So here we elaborate on the previous discussion about high resolution product images to support the business objective of increasing revenue per visitor. So we have a set of benefits articulated which talk about the fact that images or good quality images support increasing conversion rates and sales. And then we have a set of 6 acceptance criteria which talk about image size, image resolution, thumbnails, the ability to hover and zoom in and out on specific areas of the images. And then finally, we have in the template, we have a thing called a KPI, which is a key performance indicator. And in this case, it's conversion rate. So this enables us to measure over time the impact of this feature on something like conversion rate. So now let's look at how we might approach the task of ART backlog refinement. And one method of doing this is to use something called a feature intake Kanban. So a Kanban board is a set of workflow states. Each workflow state has a definition of done. And in this example, we see that features can be refined from the point where they are a one-line summary, for example, provide high-resolution images, to the point at which they are ready for PI planning. So in this example, the funnel, here's our one-line summary. The next step would be to conduct a business review, and the exit criteria for this state might be, in addition to the one-line summary, now we have a description, now we have a statement of benefits, and now we have some acceptance criteria spelled out for the feature. So we're starting now to flesh out the contents of the feature template for this feature. Then we have, once that is done, we can do a technical analysis. So a system architect would get involved, and they would figure out, well, are there any technology infrastructure implications for building this feature? So in the case of high resolution images, do we need some image compression capability? We're going to have a lot more storage needed to store all this information. What are the implications for storage capacity and database performance? And then once all that is done, we want to rank this feature relative to all other features on the ART backlog, and we'll be explaining that in a minute coming up. And then finally, once we've got all of that done, the feature is now considered ready for PI planning, and we then get the next feature done. So the last step in getting features ready for PI planning is to perform a ranking exercise. And in SAFe, the recommended ranking method is something called weighted shortest job first, or WSJF. This is based on the work by Don Reinertsen and can be found in his book, Principles of Product Development Flow. So WSJF is a method for objectively ranking and sequencing ART backlog items. It's a scheduling algorithm for ensuring work items with the highest value and lowest cost of development are ranked higher for delivery. This ensures items of the highest value are delivered at the earliest opportunity. Also, when two items have the same value, same business value, do the item of the lowest cost first, or the lowest effort first. This means this is the path to getting more value quickly into the hands of customers. It also provides teams with clarity about what to be working on. So it provides some recommendations on the sequencing of how they approach the work during execution of a PI. Also seeks to minimize work in progress. So what we have, if a team has 10 features going into a PI, what we don't want to see is 10 features in progress all at once. And ending the PI with 10 features, 90% done. So this provides a way of sequencing the work so that the highest value is de-risked to a certain extent. And then each backlog item is ranked relative to the others. So how do we do the actual WSJF calculation? So a couple of quick definitions. WSJF equals something called cost of delay divided by job size or effort, where cost of delay is the sum of three parameters: business value plus time criticality plus risk reduction opportunity. And then once we've done that, the rank is equal to simply the cost of delay divided by the job size or effort. Now, all of these parameters are all relative, sized in a relative way using Fibonacci. And so if you look at the example here we have 6 features, A through F, and the approach would be to rank each feature in terms of each parameter. So we'd start with business value. We do one column at a time before moving to the next column. And the first thing we do is we identify the item with the lowest business value, and we give that a 1. So every column every column should have at least a 1, 1. And then what we do is we rank the other features relative to that 1. And we use Fibonacci to provide some sufficient granularity and separate out the estimates. So bigger values have a higher error bar, and so a 20 simply means that it could be anywhere between a 13 and a 30 plus. An 8 means it sits somewhere between a 5 and a 13. Okay. Then we do the same for time criticality. What does time criticality means? It means how urgent is this feature. For example, it might be related to a regulatory deadline, or there may be some critical market window that we got to hit. So in which case we give this a very high score in terms of time criticality. And then risk reduction, same thing. Identify the one feature that provides the lowest opportunity for risk reduction, give it a 1, and then score everything else relative to that. And then the cost of delay is simply the sum of those 3 parameters. So for feature A, we've got the cost of delay as 16, which is basically the sum of business value plus time criticality plus risk reduction. Now, also in this case, we want to separately estimate the effort on a relative basis. And we see in this example, feature A is a 1. Feature C is going to take the largest effort, which is 13. And then the ranking, which is simply the cost of delay divided by the effort or the size. Here's the ranking score. So we see that feature B comes out with the highest rank, and feature C is coming out with the lowest rank. This probably means that feature C is not going to get done, probably likewise feature F, but we'll get to that. So to repeat, we do the scoring one column at a time for all features before moving to the next column. And we start the scoring by finding the smallest ranked item and giving it a 1. So there must be a 1 in each column. So to summarize what we covered, first of all, we covered the role of the ART backlog in SAFE. Then we took a look at features and epics and the ART backlog and the portfolio backlog. Then we looked at our approach for ART backlog refinement and PI planning readiness. And then finally, we looked at ART backlog ranking using the technique of weighted shortest job first. So now we should have most of the basic prerequisite steps covered to be able to tackle our first PI planning event. In our next section, section 4, we will be going into the details of PI planning. See you soon.